I am G. Karan Kumar, working as a lecturer in electrical and electronics engineering, and designation again institute working as Government Polytechnic Yadarigutta, Institute Government Polytechnic Yadarigutta. Today I am teaching the subject is nothing but the basic electrical engineering, that is the subject code 18E105. Topic work, power and energy. Subtopic is nothing but the problems on work, power and energy. Again here the electrical work we already studied, nothing but the electrical work is said to be done in the case of electrical circuits is nothing but by passing the current through the coil or the conductor. The mechanical work is nothing but the force into distance. That amount of the work done on a vehicle or a work done by the body to move the body through some distance is nothing but the mechanical work. Again we study the electrical power. The electrical power we can say is nothing but the again the electrical power we can study. Again here electrical power you can see nothing but the P is equal to again work done by time taken. Here the work done again we can state here in the case of electrical is nothing but the which is equal to again here V into P is equal to work done here V into I into T divided by T. T and T will get cancelled. Again we get the value is nothing but the for power P is equal to VI watts, VI measured in watts. So it is nothing but the electrical power. So we can state as the electrical power P is nothing but the ratio of voltage to current. Sorry, product of the electrical power can be defined as the product of the voltage to current measured in watts here. Again we can also define the mechanical power as nothing but the same as that of the electrical power. P is equal to work done by time taken. Work done by time taken. The work done is nothing but the again in the case of mechanical is nothing but the force into distance divided by T. Again the force Newton meter per second. Again we force F into distance by T is nothing but the again in the work done in the case of mechanical system divided by T, it can be measured Newton meter per second. Newton meter per second here. So again force measured in newtons, distance measured in meters, and time measured in seconds here. Again it is nothing but the mechanical power. Again we can write here P is equal to again work done by time taken, which can also be we can write which is equal to force into distance divided by T, or which can also be stated as the P is equal to 2 pi nt by 60, where n is nothing but the speed in RPM, T is nothing but the time required. Again pi is again the pi value is nothing but 3.14. It is nothing but the mechanical power. We can also state nothing but the electrical power, that is nothing but the power. Electrical power we can state it as P is equal to VI watts, or we can also write P is equal to I square R, or V square by R, or we can write P is equal to I square R or V square by R. Anything is same, measured in watts. It is nothing but the electrical power. So in the previous period we have discussed mechanical power, electrical power, and thermal power. Thermal power we can state it as a heat utilized, again heat that can be generated in the again coil or the conductor. We can also state is nothing by applying the voltage, current can be flows, again some heat can be generated. Again I square R or I square R, we can state it as I square or watts here. Again on completion of this period you would be able to know solve problem related to electrical power and energy. Energy we can write it as energy is nothing but the work done, total amount of the work done In case of electrical, is nothing but the energy. Again we can constitute Vi into T. Vi is nothing but the power, T is nothing but the time taken to complete the work here. So it is nothing but the energy. We can say it is the electrical energy. Electrical energy is nothing but the entire amount of the work done in the case of electrical circuit is called as electrical energy, or entire amount of the work done in the case of mechanical systems we can say is nothing but the mechanical energy here, which can be measured in joules or kilowatt hour or kWh, kilowatt hour. It is nothing but the electrical energy and mechanical energy. So solve problems relating to electrical power and energy. Again we see the problem nothing but the two coils connected. Two coils are connected in parallel and a DC voltage of 200 volts is applied to the terminals. The total current taken is 25 amperes and the power dissipated in one of the coil is 1500 watts. What is the resistance of the coil? Two coils are connected in parallel and a DC voltage of 200 volts applied to the terminals. Again we can assume nothing but the again two coils that can be, again we can assume here so we can assume here two coils are connected, or resistance or coils which can be connected in the parallel, which can be connected to the voltage that is nothing but the again 200 volts dissipated in one of the coil is 1500 watts. The coil we can say is nothing but the 1500 watts. Current taken is nothing but the 25 amperes. Voltage we are applying is nothing but 200 volts. So what is the resistance of the each coil? So we have to find out R1 and R2 here. So here given two coils are connected in parallel, so we can assume again two coils are connected in the parallel. Again where the voltage to the 200 volts is applied to the terminals, the total current is taken, that is nothing but the 25 amperes, and the power dissipated in one of the coil is 1500 watts. That is we can say the power P is equal to 1500 watts. So what is the resistance of each coil? So we have to find out R1 and R2. So first we have to write the given data, that is nothing but the voltage V is equal to 200 volts, total current I is equal to 25 amperes, and the power dissipated in one of the again coil is 1500 watts. So P is equal to 1500 watts, current I is equal to 25 amperes. What is the resistance of each coil? So that is nothing but the R1 R2 is equal to how much? So that is given data. V is equal to 200 volts, I is equal to 25 amperes, P1 is equal to 1500 watts, R1 R2 is equal to how much here? So we know I according to Ohm's law, again here the power value is equal to P is equal to V into I. I1 is equal to P1 by V. Again which is equal to power given as 1500 by 200, which is equal to 7.5 amperes. So again we can write here current I is equal to, in the case of parallel circuit the current can be divided, that is I is equal to I1 plus I2. So again we can write here I2 is equal to I minus I1. I minus I1, that is nothing but the current I2. 25 minus 7.5, which is equal to 17.5 amperes. Again the current I is equal to 25 amperes, I1 is equal to 7.5 amperes, that is the 17.5 amperes. Again R1 is equal to V by R1. According to Ohm's law we know that here according to Ohm's law I is equal to V by R. Here the parallel circuit is nothing but the current can be divided. Again we can write R1 is equal to V by I1. So I1 is equal to 7.5, which is equal to 200 by 7.5, which is equal to 26.67 ohms. 26.67 ohms here. So R1 is equal to, so 200 by 7.5, which is equal to 26.67 ohms. Again R2 is equal to V by I2. Again I2 is equal to 17.5 amperes. Again which is equal to 200 by 17.5, which is equal to 11.429 ohms. Again here, so this is the given data. Again here the resistance, two coils are connected in parallel. So parallel is nothing but the, again the conditions in the case of parallel circuit is nothing but the, once we go again the problem, again current condition in the case of parallel circuit I is equal to I1 plus I2. The current can be divided and the voltage remains the same. V is equal to V1 is equal to V2. V is equal to V1 is equal to V2. Again the current can be divided, that is I is equal to I1 plus I2 here. So here again we have to find out the values of the R1 and R2. So again we know that power P is equal to V into I. Again here I1 we can say P1. Again we have to find out the I1 P1 by V, given I1 is equal to, again here again we have to find out the value of I1 given power, that is the power P1 1500 watts V. Again we can find the value of I1 here. Again that is 1500 by 200, 7.5 amperes. I2 is equal to I minus I1. Again here 25 minus 7.5, which is equal to 17.5 amperes. Again here R1 is equal to V by I1, which is equal to 200 by 7.5 ampere, that is the 26.67 ohms. Again R2 is equal to V by I2. Again here 200 by 17.5 ampere, that is equal to 11.429 ohms. So R1 is equal to 26.61 ohms, R2 is equal to 11.429 ohms here. Again next problem is nothing but what is the cost of running 5 HP motor of efficiency 80% at a full load for 24 hours at 80 paise per minute. So cost of running 5 HP motors, which we can write here nothing but the, again power P is nothing but a 5 HP. So 1 HP we can write here, 1 horsepower is nothing but equal to 735.5 watts here. Watts. Efficiency given, that is nothing but 80% for 24 hours at 80 paise per minute. So given data, that is nothing but the output is equal to 5 HP. Again that is efficiency is equal to 80%. Output efficiency given, again we can find the input value. T is equal to 24 hours. Rate is equal to 80 paise per kilowatt hour here. So what is the cost of running 500 HP motor? So 5 HP motor, we have to find the value of the cost. Efficiency of motor is 80% at full load for 24 hours at 80 paise per minute, 80 paise per kilowatt hour. So cost is equal to how much? And we can find output power is equal to 5 into 735.5. Again we know 1 HP is equal to 735.5 watts. Again here, which is equal to 3677.5 watts. Again input power is equal to output by efficiency. Again we know here efficiency, it can be defined as ratio of output by input. So again we can find out the value of the input. Input is nothing but output divided by efficiency. Again nothing but input is equal to output divided by efficiency. So input power is equal to output by efficiency, which is equal to 3677.5 divided by efficiency is equal to 0.8. Again efficiency is given as the efficiency is equal to 80%. Again we can write it as 80 divided by 100. So which is equal to 0.8. So here 3677.5 divided by 0.8, which is equal to, we get 4596.875 watts. Again energy input, which is equal to power into time. Input is equal to, again nothing but the, again energy, again we can calculate is nothing but a VIT, that is the work done in the case of electrical circuits here. So which is equal to power is equal to 4596.875 into 25 divided by 1000. Again 110.325 kilowatt hour. Again cost of energy is equal to, again 110.325 into 80 by 100. So even 80 paise per, that is a 80 divided by 100, which is equal to rupees 88.26 paise. So here again we go for Again it is given 80 paise per minute. Again 80 divided by 100 divided by 1 kilowatt hour. So we have to find out the cost of running 5 HP motor. So again efficiency 80% of full load 24 hours, 80 paise per unit here. So given here output is equal to 5 HP, efficiency and cost 24 hours at 80 paise per minute. So output is equal to 5 HP, efficiency is equal to 80%, time t is equal to 24 hours. So rate is equal to 80 paise per kilowatt hour. So what is the cost we have to find out. So again output is equal to 5 HP, that is again we know 5 into 735.5. So again we know your efficiency, that is again we can calculate nothing but your efficiency is equal to output by input. So output is equal to again input is equal to output by efficiency. We can find out the input power. So that is given output is equal to 5 into 735.1 HP is equal to 735.5 here. Again input power is equal to output by efficiency is equal to 3677.5 divided by 0.8 is equal to 4596.875 watts. Again energy input is equal to power into time, 4596.875 into 24 by 1000. Given input power is equal to output by efficiency, that is equal to 3677.5 divided by 0.8. Given 80%, so we can nothing but efficiency given 80%. So 80 divided by 100 is equal to 0.8, which is equal to 4596.875 watts. So energy input is equal to power into time, which is equal to 4596.875 into 24 by 1000. In that invert again we get which is equal to 110.325 kilowatt hour. That is the cost of energy, which is equal to 110.325 into 80 divided by 100. Again which is equal to rupees 88.26 pice. So it is the cost of energy that consumed by the running the again 5 HP motor, that is the rupees 88.26 pice here. Next one, a residential house has the following loads, that is a 10 lamps of 60 working for 8 hours per day, 6 lamps of 100 watts working for 5 hours per day, 5 fans of 80 watts working for 12 hours per day, 2 heaters of 1000 watts working for 3 hours. 5 fans of 80 watts working for 12 hours per day, 2 heaters of 1000 watts working for 3 hours per day, and 1 half HP pump set of energy efficiency 85% running 2 hours per day. Calculate the monthly electricity bill at the rate of rupees 1.35 for first 50 units and rupees 2.15 for the remaining units. Add 310 as a meter rent per month. So given it is a residential house which is having the 60 lamps of 60 watts working for 8 hours per day. So 10 lamps of 60 watts, each rating of the lamp is 60, working for 8 hours per day here. Again we have to multiply again 6 lamps of 100 watts working for 5 hours per day, 5 fans of 80 watts working for 12 hours per day, 6 lamps again which is having the again rating of 100 watts working for 5 hours per day, 5 fans of 80 watts, again each fan having the 80 watts, wattage is 80 watts working for 12 hours per day, 2 heaters rating is, each heater rating is again here 1000 watts, again working for 3 hours per day, 1 half HP pump set of efficiency 85% running 2 hours per day. Calculate the monthly electricity. So we have to calculate the monthly electricity bill for rupees given 1.35 for first 50 units and rupees 2.15 for the remaining units. Add rupees 10 as per meter rent per month. So here given serial number, particulars and the number of hours per day, it is a quality, wattage, total power and energy per day, watt hours here. So these are the again serial numbers. What is the total power? That is the quantity into wattage. Again given first serial number 1. Particulars bulbs, electrical bulbs are given nothing but the 8. Working in number of hours per day 8 here. Quantity given as a 10, that is a wattage, that is a 60 watts each on each bulb, that is having 60 watts here. Again here 10 into 60, again 600, again here again then nothing but the 600 again 10 into 60, that is the wattage 600 here. Again energy per day watt hour, that is a 6 into 3, 6 into 3 is nothing but the your number of hours 600 into 8 into 8, so we get 4800. It is a watt hour. Again 4800. Again bulbs 5, again 6, wattage is 100 watts, quantity 600 watts, when total power, that is a 600, again 3000. Again here 600 into again 5, that is a 3000. 6 into 100 is nothing but the 600. Third one, fans, number of hours working 12 hours, quantity is nothing but the 5, wattage is 80. Again here 400, again we get 4800, that is a again 400 into 12, that is a again 4800 watt hour. Fourth, given as a heaters, again work for 3 hours per day. Again here quantity, that is a 2, again wattage 1000, again total power 2000 here, again here 6000, again 5, pump set, again 2, quality is 1, again 432.65 total power and energy. Again, so these are the energy calculation bill. First year given as the bulbs, number of bulbs given, working for number of hours per day, that is the 8, quantity 10 bulbs are given, each bulb having the 60 watts. So total power watts, so total power watts is nothing but the again given quantity into wattage, that is a 10 into 6, 10 into 60, that is a 600, 10 into 6, that is 600. Again this 600 again energy per day, so power consumed into again number of hours time taken, that is a 8, that is a 4800 watts. Next again given the bulbs here, again here given as a number of hours per day working 5, quantity 6, again given wattage 100, again give total power, that is 100 into 6, that is a 600, again 600 into 5, that is a 3000. Given fans, that is nothing but the 12, again a quantity given 5 here, again wattage 80, again total power, that is nothing but the 400 into again here into 12, that is the 4800 watts. Heaters given as working for number of hours 3, quantity 2 heaters, each rating is nothing but the 1000. Again here total power is nothing, again 100,000 into 2, that is a 2000, again 1000 into 3, again 2000 into 3, that is nothing but 6000, that is the energy for day. Again pump set given as only one, that is the pump set given, again number of hours working per day is 2, again here wattage, that is given as 432.65, again 432.65 into 1, that is 430.65, energy per day 430.65 into 2, that is given 865.3 here. So that is given total 4800, 3000, 40, again we have to add all of this, again we get the 19465.3 here. So total energy per day is nothing but the 19465.3. So energy consumption per day, the total energy consumption per day is equal to 19465.3 watt hour. Convert in kilowatt hour, again nothing but divide by 1000. Divided by 1000, again we get the kilowatt hour, that is the 19.4653 kilowatt hour. Again, energy consumption per month is equal to 19.463 19.4653 into 30, that is the 1 month is equal to 30 days here. Again, energy consumption per month 19.4653 into 30, that is nothing but 583.958. Again, the monthly bill, that is energy cost plus meter rent. Given energy cost, that is rupees 1.35 into 50 plus 2.95 into 534 plus rupees 10, which is equal to rupees 1642.80 plus 10 year. So again, rupees 1 into 50 plus 2.95 into 534 plus rupees 10, which is equal to 1642.80 plus 10 year. Which is equal to rupees 1652.80 pice. So monthly bill is equal to 1652.8 pice here. So given here 1.35. So for first 50 units again is equal to nothing but the, again last we have to calculate nothing but 1.35 into 50 for first 50 units plus again rupees 2.15 for remaining, that is again we calculated again 534, 2.15 into 534 remaining units, and add rupees 80 as meter rent per month, so plus 10 rupees, again we get the total monthly bill. So in this way we have to calculate the bill here. So again here we have to mark nothing but the, again table like this, particulars, number of hours, quantity, wattage, total power and water. So later we have to convert in kilowatt hour. Again we have to add all the energy consumed per day when these are the. So these are the, again, so in this way we have to calculate number of hours working per day, quantity, wattage. Again we have to multiply again here wattage into quantity. Later energy consumed we have to calculate here total wattage into number of hours per day here. So that is 600 into 5, we get the 3000. Again same we have to calculate for fans, again 12 hours, that is the 580. Again we get the total 4800. Again for the heaters working for 3 hours, again we get total watt hour 6005. That is the pump set, again we get here, that is nothing but the 865.3. total we have to add, again we get 19465.3. again we get energy consumption per day, that is on 19465.3 watt hour. Again we have to convert in kilowatt hour, again we get here 19.4653 kilowatt hour. Again energy consumption per month, which is equal to 19.4653 into 30, that which is equal to 583.958. again we get monthly bill is equal to energy cost per meter rent. So that is nothing but the, again energy cost, again rupees 1.35 into 50 plus remaining units, so we have to minus. So that is nothing but the, again 583.958 minus 50 here, so get 534. So 2.95 into remaining unit, that is a 534 plus meter rent, that is a, again 10. Again we get rupees 1642.80 plus 10, and we get rupees 1652.80 pice here. So it is a monthly electricity bill. So given it is a, again next problem, that is electrical pump gravity. So tank given here, tank again the length of the tank is nothing but the 2 meters. Again the height of the tank is nothing but 10 meters. Again pump given, again electric pump. So work done by the motor pump to lift 3000 kg mass of the water through the height of 10 meters against gravity is m into g into height, which is equal to 3000 into 9.81 into 10. So 1 gram is equal to 9.81 newtons, which is equal to 10. Is nothing but 294 300 kg meters here. That is, this much of work is to be done by the motor in a time of 30 minutes or 30 into 60 seconds here. So 1 minute is equal to 60 seconds. So 1 minute is equal to 60 seconds. So work done by the motor in 1 second will be 294 300 by 30 into 60 by kg meter per second, again which is equal to 163.5 kg meter per second. We know that 75 kg meter per second work done is equal to 1 HP, that is equal to 163.5 kg meter per second of power in HP, that is which is equal to 163.5, again divided by 75, which is equal to 2.18 HP. So kg meter per second convert in 1 HP, again we get here 163.5 divided by 75, we get 2.18 HP. The output power capacity of the motor is 2.18 HP. Given a water tank of the capacity 5000 liters at a height of 12 meters is to be filled up with water by the means of an electrical motor pump set is half hour. On a half hour time, the motor pump is connected to a supply of 230 volts and draws a current of 21.5 amperes. Again, from the supply, determine the output power capacity of the pump set, its efficiency. Again, given the water tank of the capacity 5000 liters, so 1 liter is equal to 5000 kg here. So 1 liter, again we can write here nothing but the, again 1 liter is equal to 1 kg. 1 liter is equal to 1 kg. Again, that is nothing but the 5000 liters is equal to 5000 kg at a height capacity 5000 kg liters at a height of 12 meters to be filled up with the water by the means of an electrical motor pump set is a half hour time. The motor pump is connected to supply 230 volts and draws the given current I is equal to 21.5 amperes. So determine the output power capacity of the pump set and its efficiency. So given capacity of the tank is 5000 liters and mass of the 5000 liters of the water is equal to nothing but the kg, that is the 5000 kg. Work done by the pump while lifting 5000 kg mass of water through a height of 12 meters against gravity, that is nothing but again m into g into height. So mass into gram into height here. The work done is equal to work done, first we have to find out the work done. It is the 5000 mass into height into grams, that is the 5000 into 9.81 into 12 kg meter. Again we get 58866 588,600 kg meters. Again the work is to be done by the pump set in half hour, or which is equal to 30 into 60, half hour. So half hour is equal to nothing but the 30 into 60 seconds. So 30 minutes, half hour is equal to nothing but 30 minutes. 1 minute is equal to 60 seconds here. So half, again we can calculate is nothing but 30 minutes, which is equal to 30 into 60. Which is equal to work done by the pump in 1 second, by the total work done by time taken, which is equal to again 588,600 by 30 into 60 kg meters per second here. It is 327 kg meter per second. So converting into HP, that is the 327 by divided by 75, which is equal to 4.336 HP here. So it is a tank capacity 5000 liters, 12 meters. Again given electrical pump. The output power capacity of the pump is 4.36 HP. Given here, it is nothing but the pump. again it is nothing but the pump here. So output of the pump is what work done by the tank in seconds here. The output power of the capacity of the pump is 4.36 HP, which is equal to 4.36 into 735.5, again which is equal to 3206.78 watts. Again the electrical power input to the motor, which is equal to 230 into 21.5, which is equal to 4945 watts. Again efficiency of the motor pump is equal to output power divided by input power into 100. Again 3206.778 by 4945 into 100, again 64.85%. And efficiency of the motor pump, nothing, output power by divided by input power into 100 here. So output power of the pump is nothing but the input power. Output power is equal to 3206 again divided by input power, 495 into 100. So again efficiency equal to output by input, that is nothing but 64.85% here. So next one, again electrical motor driven motor, that is a pump, water pump of the 3 HP capacity, pumps out water is 0.002 meter cube per second. Calculate the height through which the water can be pumped. Also find the current on the supply 230 volts by connected motor if the efficiency of the pump and the motor is 85% respectively. So given here output of the pump, that is a 3 HP, 1 HP is equal to 735.5 and 1 HP is equal to 735.5. So it is nothing but the output of the pump, output of the motor driving pump is nothing but the in 3 HP, that is a 3 into 735.5, we get the watts output power, and that is in given meter cube, time is nothing but seconds. Calculate the height, HP have to calculate, efficiency given here 85%. Then we can find the first input. Again we can find the input power, that is nothing but the input power, which is equal to P. Again we can find pi, so I is equal to current P by V here. So in this way we can calculate. So given quantity of the water coming out of the pump, that which is equal to 0.002 meter cube per second. Again that is the mass of the water coming out of the pump in 1 second, which is equal to 0.002 into 1000 kg. Again force of this mass of the water has to be 0.002 into 1000 into 9.8 kg. Again given mass of the motor out of the pump in 1 second, 0.002 into 1000 kg. So here work done by the pump is again for lifting of the water is nothing but the mass into again height into grams. So that is force of the water of the motor has to be again 0.010,000 into 9.81 kg. So which is going to let the height through the which of the pump can deliver water be h meters. Again height is nothing but h meters. So work done by the pump in 1 second is force into height, that is a 0.002 into again 1000 into 9.81 into h meter, that is again h meters we have to calculate kg meter per second here. So we know that 75 kg meter per second of work done is equal to 1 HP. Again horsepower of the motor will be again which is equal to 0.002 into 1000 into 9.81 into h by 75, that which is equal to equating this to the given HP of the pump, that is a 0.002 into 1000 into 9.81 h by 75, which is equal to 3, and h is equal to 3 into 0.002 into 1000 into 9.81, in which is equal to 11.4678 meters. So input to the pump again which is equal to output of the pump by efficiency of the pump into 100, nothing but the input of the, again we can again nothing but the output is equal to, in efficiency is equal to output by input. Efficiency is equal to output by input. Again here nothing but the input is nothing but the output by efficiency into 100. So which is equal to, again h is equal to 3 into 75 divided by, again height we can calculate in nothing but, again we have to cross multiply, that is nothing but the h is equal to 3 into 75 divided by 0.002 into 1000 into 9.81, which is equal to 11.4678 meters. So input is equal to output by efficiency. Again here 3 HP by 85 into 100, again which is equal to 3.5294 HP. Again input of the pump is equal to output of the motor. And which is equal to 3.52894 HP here. So or 3.5294 into 735.5 watts, which is equal to again 2595.875 watts. So electrical power input to the motor, that is the output by output of the motor divided by efficiency of the motor into 100, is equal to 2595.874 into divided by 80 into 100 watts. So which is equal to, we get 3244.84 watts here. So input of the motor, again input power to the motor, which is equal to VI. Again I is equal to P by V. So again we know here P is equal to VI and I is equal to P by V. Again we get which is equal to 14.108 amperes. I is equal to, again it is the, this way we have to calculate. Again nothing but here given, here we can state nothing but the, here it is the height, it is the tank. So here water can be filled here. Again we are playing the motor. From the motor here the pump can be provided. From the pipe the water can be lifted here. So it is nothing but the motor and the pump. Here supply we are giving. So input is nothing but, input to the motor is nothing but the supply, that is the power P. The output of the motor is output of the motor is nothing but the input of the pump, and output of the pump is nothing but the work done by the pump per second here. So again it is nothing but the motor, it is nothing but the pump here. So input supply we are giving is nothing but the, that is the input, that is nothing but the P, and output of the motor is nothing but the input of the pump. Output of the pump is nothing but the work done by the pump per second here, that is the lifting of the water through the height of H meters. So it is nothing but the height of H meters. So we have to calculate here. So in this way we have to do. Again 2 lamps of rating 220 volts 60 watts and 220 volts again 100 watts are connected in series across 220 volt supply. We have to calculate the voltage across each lamp and power consumption. So what will be the power consumption if the 2 lamps are connected in parallel? So again 2 lamps are connected in series across the 230 volt supply. Again series combination is nothing but 2 lamps, and we have to map like this. 2 lamps are connected in series, which is together is connected to the, again voltage of 220 volts. Again 220 volts 60 watts, 220 volts 100 watts, 60 watts and 100 watts given here, which is connected to 230 volts. Calculate the voltage across each lamp and power consumption. So again we know, again in the case of series combination, the voltage can be divided, that is the V is equal to V1 plus V2. V1 is equal to, again nothing but here again IR, or we can also constitute here nothing but the P is equal to V by V into IR, V into V1 into I. Power P1 is equal to V1 into IR. Power P1 is given is nothing but 60 watts and V1 given 220 volts here. So I we can calculate here. So given here solution, given data, that is nothing but V is equal to 220 volts, P1 is equal to 60 watts and P2 is equal to 100 watts here. So given V voltage P1 is 60 watts, P2 is equal to 100 watts, V1, V2 is equal to how much, P is equal to how much here. So resistance of 60 watt lamp R1 is equal to V square by P1, which is equal to 220 square by 60. Again here 806.7 ohms. Given resistance of 100 watts lamp R2 is equal to again 200 square by 100. That is again we get R2 is equal to 484 ohms here. So again we know again P is equal to V square by R. V square by R. So again we calculate R is equal to V square by P. So again total resistance when connected in series, that is nothing but the given R is equal to R1 plus R2, which is equal to 806.7 plus 484, again which is equal to 1290.7, which is equal to 1290.7. Again current I is equal to V bar, which is equal to 220 by 1290.7, again which is equal to 0.1704 amperes. Again, so voltage across 60 watt lamp V1 is equal to I into R1, which is equal to 0.1704 into 806.7, again which is equal to 137.5 volts. So again, so voltage across 100 watts lamp V2 is equal to I into R2, so which is equal to again 0.1704 into 434.84. So voltage across 60 watt lamp, that is nothing but a V1 is equal to I into R according to Ohm's law. I is equal to V by R, V is equal to I into R here. So IR1, that is nothing but 0.1704 into 806.7, which is equal to 137.5. So voltage across 100 watt lamp, which is equal to V2 is equal to IR2, again which is equal to 0.1704 into 484, so which is equal to 82.5 volts. So power consumption P is equal to V into I, which is equal to 220 into 0.1704, again which is equal to 37.5 watts. So again when the lamps are connected in parallel, the power consumption P is equal to 60 plus 100, which is equal to 160 watts here. So given 3 lamps of rating 230 volts, 100 watts, 200 watts and 500 watts are connected in parallel across 200 volt supply. Calculate the power dissipation of each lamp at 200 volt supply. Please stop. Also calculate the resistance of each lamp. That is the voltage rating of each lamp is equal to 230 volts. That is the voltage applied to the each lamp is 200 volts. So given resistance of the 100 watt lamp R1 is equal to V square by P1, which is equal to 230 square by 100, which is equal to 529 ohms. Resistance of 200 watts lamp R2 is equal to V square by P2, which is equal to 230 square by 200, and which is equal to 264.5 amps here. Again resistance of 500 watts lamp, that is R3 is equal to V square by P3, which is equal to 230 square by 500, again 105.8. Again power dissipation of the 100 watt lamp is 200 volts, again which is equal to V square by R1, again which is equal to 200 square by 529, which is equal to 75.6 watts. So power dissipation of 200 watts lamp at 200 volts, which is equal to V square by R2, which is equal to 200 square by 264, which is equal to 151.23 watts here. So power dissipation of 500 watts lamp at 200 volts, which is V square by R3, which is equal to 200 square by 105.8, which is equal to 378.1 watts. So okay, thank you.